Mm. Y. Oh, I know one. I got to remember all my keys. Okay. So Monday's lab is all about making measurements. And specifically, it is understanding the reliability of those measurements. It's understanding the difference between precision and accuracy. And it's about determining what instrument is going to give you the best data. So when a scientist reports a measured quantity, they do so that the reported significant digits reflects the certainty of the measurement. This certainty, folks, it tells me how good the instrument is. Am I able to only measure to 1 decimal place? Or can I measure to 2 decimal places? If I can measure to 2 decimal places, I'm going to get better data. I'm going to get more precise data. And probably because that instrument measures to 2 decimal places, my data is going to be more accurate than that one that only gave me 1 decimal place. So that certainty makes a huge difference. By the way, you will note one thing that I did not get up until this morning were these slides. However, I will work on the slides for next week, this weekend, and post them by Monday. So you'll have the slides that I'm going to work off of. This is new for me. I was writing it all out previously, so. Okay. Ooh, I don't like how small that is. Can I make it bigger? This isn't going to allow me to make it bigger until I figure out my settings. Okay, there's going to be 2 types of instruments that we were going to use. The first type of instrument is going to be the toughest in order to get an accurate measurement with. It is called an analog instrument. Analog measurements. When you record a measurement that is from an analog instrument, analog means that you have to read markings. It's not digital. That's what it means. It's not digital. When reporting an analog measurement, the goal is to represent both the value obtained and the inherent uncertainty due to the instrument's limitations. What that means is you're going to read the digits you can read with certainty. Those are going to be the smallest division on the measuring device, and read the measurement to the nearest marked value. Any markings means that you can read it with certainty. And then you're going to estimate the last digit. That is your uncertain digit. In other words, folks, you're going to ask yourself some questions. Such as, can I read the tens place? Meaning, is there a mark for 10? Is there a mark for 20? Is there a mark for 30? Can I read the ones place? Meaning, is there a mark for 21? Is there a mark for 22? Is there a mark for 23? Can I read the tens place? Meaning, is there a mark for 21.1? Is there a mark for 21.2? Is there a mark for 21.3? You keep asking those questions until you say no. When you say no, that is your estimated digit. When you say no, I can't read a mark for that. That is your estimated digit. That's the last digit you record. Digital, folks, is much easier. You just record whatever you see. Whatever the instrument tells you, you just record it. It takes into account the digits of certain digits and that estimated digit. It's the analog that's the challenge. And what we're about to do is we're going to practice on a few real quick. Now, I want to say one more thing before I start practicing. A value without a unit is meaningless. A value without a unit is meaningless. It's around 25 in here. Well, it sure isn't 25 degrees Fahrenheit. That would mean it's below freezing. It definitely doesn't mean it's 25 Kelvin. Because at that point, we're getting pretty close to all molecules ceasing to move. The only unit that makes sense with that 25 degrees is that it had to be Celsius. So a unit or a measurement without a unit is absolutely meaningless. So always record your units. So let's look at these two. This top right one, if I record it, I would record it as 10.5 grams because it's digital. I record what I can see. This other one, if I record it, I'm going to record 10.4977 grams because it's digital. I'm going to record what I can see. Now, with respect to these two devices, this one is going to give you much greater precision. It's going to give you much greater precision because you can read to more decimal places. And if it's calibrated, this one's going to be more accurate because you can read to more decimal places. Again, digital is easy. Let's look at analog. First of all, when you see a meniscus, you always read at the bottom of the meniscus. Therefore, I am going to read whatever I think this is. Now, here's where we go and ask those questions. Can we read the ones place? Can I read 4? Can I read 5? Can I read 3? Yes. So I can read the ones place. Can I read the tens place? Meaning, can I read 4.1, 4.2, 4.3? Is there a mark for those? Yes. Meaning I can read the tens Is there a mark for 4.11, 4.12, 4.13? I see a lot of heads shaking. That's your estimated digit. When you say no, that's your estimated digit. So with this particular one, I would read it as 4.57 milliliters. You may have read it as 4.58. You may have read it as 4.56. You may have read it as 4.59. All of those answers would be acceptable. That's what that estimated digit is. It's that digit of uncertainty. It's that digit that usually is related to the individual and how they interpret it. Now, one thing that will help us is when we read this, we need to be eye level. Don't read it pointing down. If you read it pointing down, you're going to get what's called a parallax error. Meaning it's going to, ultimately meaning it's going to be an incorrect measurement. Always read eye level with the meniscus. With your devices that you're going to use in the laboratory, that may mean you have to sit down or get further down, or it may mean that you have to move the instrument up and down, but read it at eye level. That way you don't have a parallax error. Okay, let's look at this next one. This one doesn't have as much of a meniscus, but I'm going to read at the bottom of what meniscus does exist. Okay. What I see is 120. What would that line be associated with? 130, 140. Meaning I can read the hundreds place, and I can read the tens place. Now, between 120 and 130, is there a mark for 121, 122, 123? There's not a mark for all of them. So the ones place is your estimated digit. Therefore, with this device, I would read it as 143 milliliters. And I would quit at 143 because that is my estimated digit. Okay, I know this is kind of crooked. Or not crooked, but sideways, whatever. Take a moment and I want you to think about what you would read it as. That one that says 10 is 110. It's the way the thermometer works. They just start over at 10 again. Were you able to read the hundreds place? Yes, what was it? 100. I'm going to move that over so that it's got a brighter thing. Were you able to read the tens place? So what is it? 0. Were you able to read the ones place? Yes. What did you think it is?
103. Were you able to read the 10th place? So that's your estimated digit. I would read this as 103.0 degrees Celsius.
You may have read that as 102.9. Ow. You may have read it as 103.1. That's okay, as long as our differences are occurring in that 10th place. Now notice that I made sure to include a 10th place, even though I read it as 0. If it's perfectly on the line, your estimated digit is going to be a 0. But you still have to have an estimated digit. Okay, those last, the first 2 analog examples I gave you were for devices that are going to be labeled as TC, meaning to contain. They read from bottom to top, meaning one's at the very bottom, 2, 3, 4, 5, 6, and so on. The devices that I have up now would be labeled as TD, to distribute. To distribute devices, read from top down. What I'm trying to get at with that is you always read from the lowest number. So take a minute, well, not even that long. Take a second and go, okay, which way am I going to read? Bottom to top or top to bottom? In this case, I'm going to read top to bottom because 9 is here, 10, 11. I always read from the lowest number. Again, I'm reading at the bottom of the meniscus. So it's going to be 10. Can I read 10.1? 10.2? 10.3? Yes. That means I have to include the 10th place. Can I read 10.01, 10.02, 10.03? Is there a mark for those? No. That means that that is my estimated digit. So I'm going to need 2 decimal places. Now, because this looks to me to be perfectly on the line, I would record that as 10.00 milliliters. What would you read this one as? That's a very good point. So how many see it as, so first of all, how many say I should record 1 decimal place as my estimated digit? How many say 2 decimal places is the estimated digit? Okay, that is correct. The estimated digit is at the 2 decimal place point. So let's see, this is 43.1. 2, 3, 4, 5, 6. So because of my line, it's really hard to tell. I would have probably said 43.60 milliliters. Any questions? On Monday, you will be reading some instruments. I will have to do a little bit of lecture Monday at the start of lab because I need to talk about how to do some calculations with these measurements. But in general, the big thing is learning how to do measurements on Monday. I will see you Monday.